Hi, I'm Jim, and this is my Draw My Life. My father is Grandpa Graphy, and my two sons are John and Al. This is Grandpa Graphy. He's been around since around the 18th century. He's pretty old. Grandpa was very useful from the start. He allowed ways for programmers to display and follow data along a constant flow. Grandpa's a bit bipolar though, and sometimes he was directed and other times completely undirected. But the nice thing was, either way, people learned how to utilize him. The way he works is by using what are called nodes. These are used to store some sort of value. Grandpa was very precise, so he used pointers to connect each of these nodes. These connections were known as edges. For some situations, people needed a different way to display a flow of data that could only go in one direction. For example, mapping out a traffic plan or street layout for a city. This actually uses both directed and undirected, as they need to know which streets will have traffic both ways and which will be one ways. Grandpa was always so useful. Well, I guess that brings us to me. Like I said, my name's Jim, the single source shortest path algorithm. What this means is that I'm very good at being able to find the path from any point in the graph that Grandpa taught me about to any other point within it. However, when it comes to looking at all the points on the graph, I'm just no good. Grandpa Graphy used to talk about a cousin of mine, Faraz, the all-pair shortest path algorithm, but we won't talk about him. This is all about me. So I can explain how I work a little better with the help of my great drawing skills. I can look at any point within our graph and find the shortest path to any other point in the graph. I can do this for any of our vertices, but not for all of them at once. Like I said, that's more my cousin's thing. If you give me enough time, I could fill all the paths, but he's just way better at it than I am. Now this is my son John. John is very greedy. Greedy algorithms take the best value that it can find and repeats it until there are no more available options. His complexity is big O of V times E, where V is the number of vertices and edges is E. This is because he needs to loop through each vertex, and for each vertex he needs to loop through each edge. Therefore, we get a complexity of big O of VE. Specifically, he follows what's called the Dijkstra algorithm. This algorithm is as follows. Firstly, he takes a graph like Grampy. Then he uses his skills to do the job of finding the SSSP, or single source shortest path. Firstly, he finds an initial node and sets its value at 0, and sets all other nodes' values to a tentative value of 0 as well. Along the way, he keeps a set of all the visited and unvisited nodes to reference later when he needs them. Then, for the current node, he considers all of its unvisited neighbors and calculates the distance value using the formula distance to the current node we're on and distance from the current node to the neighbor node. If this is less than the tentative value that is stored in the node, then it replaces it. When he is done considering all of the neighbors of the current node, he puts the node in the visited set and removes it from the unvisited set. He knows now when he is finished once the destination node is marked and visited. But until he has finished, he marks the unvisited node with the smallest tentative value as the current node, and repeats the process from the step of considering all of the unvisited neighbors. Once he is finished, he has a single source shortest path. Hey, kind of like me. So John's occupation is a map maker. This best fits his abilities because he's able to find the shortest path between two locations. John is always moving forward and a very positive thinker. He has major setbacks when he comes across any sort of negative values. He relies on the fact that picking a path forward can never make that path shorter. Showing negative distances on a map would be impossible. So he just sticks to maps and gets paid well to do it. This is my son Al. He is very dynamic. Dynamic algorithms take a larger problem and break them down into smaller subproblems. He specifically follows the Bellman-Ford algorithm. Unlike John, he would start at infinity and narrow himself down from there. He would start at the first node and consider the distance to all other nodes to be infinity. He then finds the shortest path to all nodes with at most one edge, and then two edges, and so on. As he progresses through this process, the shortest distances to the other nodes get smaller and smaller. Since the most edges that a path can have is the total number of vertices, minus 1, the last iteration is the shortest path with at most v minus 1 edges, or the number of vertices minus 1. But only if there are no negative cycles. Al's a pretty complex guy, just like his brother. The complexity of big O of v times e as well. The number of vertices is multiplied by the number of edges here, just as we see in our previous complexity. But Al's ability to handle negatives sets him apart from his brother Jim. Since he can handle negatives, he has a job as a banker, which is odd since Jim is the greedy one. But being able to handle negative values allows him to handle both withdrawals as well as deposits from bank accounts. However, as mentioned, Al doesn't like negative cycles in life. He gets a little stuck in a cycle and he stops what he's doing and moves on to something else. Well, that pretty much sums up our family tree. I hope you've enjoyed hearing about me, Jim, the single source shortest path algorithm. And I've sure enjoyed sharing my life with you. And I hope you've learned something and you can take it away. Have a lovely day.